Number 5. The measurement of angle A is 41 degrees, side A is 6, and side C is 8. We have an angle and two sides. Furthermore, we have a side opposite an angle. Let's take a look. We have a given side opposite an angle. In addition, it's smaller than the adjacent side. That means it's possible that we could swing it over to form another triangle within, but we need to mathematically check it. Let's take a closer look. Before we check it, what if the opposite side is greater than the adjacent side? And what if we swing it over to form another triangle? Well, it won't be within to utilize the given angle or use the given angle. So no, we can't. Okay, now let's check if the given opposite side is long enough. So draw the height or the amplitude of the triangle and solve for it to compare it to the given opposite side to the angle. Let's focus here on the right triangle within. We know that sine of an angle is the opposite over the hypotenuse. That is, sine of 41 degrees is the unknown height over 8. Then multiply both sides by 8, then we get the height to be 5.25 approximately. Now, since the height, which is 5.25, is less than the given opposite side, which is 6, to the given angle, and at the same time, it's less than the adjacent side, which is 8, then we can for sure form another triangle within, like this. All this means that two triangles can be formed. Now, let's move on to solve the outer triangle, or let's call it triangle 1. And label every part accordingly and logically, including the missing parts, like the way you see it here. The missing parts are angle B, angle C, and side B. And for the other triangle or triangle 2, label them with prime notation for the comparable parts. Now let's go back and solve the triangle 1 for its missing parts. With the law of sines, angle C could be solved first. I'll have you take a look and pause if necessary. Angle B is next, with the sum of the interior of a triangle being 180 degrees. You can see how it can be solved. Side B would be the last for this triangle. Using the law of sines again with the angle B, you could see how it's done. Now let's go and solve the triangle 2. To do this, we need to use the part or angle C from triangle 1. If you notice, the triangle 2 has the 6 units being the opposite side to the same angle, which is 41 degrees. It formed an isosceles triangle, and according to geometry, if a triangle is isosceles, the base angles are congruent. Continuing, solving for angle C prime, the two adjacent angles form a straight angle. Together they are supplementary and add up to 180 degrees. Next, angle B prime. The sum of the interior angles of a triangle is 180 degrees, and we solved. And last, very last, side B prime. Using the law of sines once again, with the solved angle B prime, we can get the work done. Thank you for watching and happy study, everyone.